So in the end, it's all about greenhouse gas emissions. Okay? But we're emitting different greenhouse gases. CO2, but also methane and nitrous oxide. Okay, so in order to compare different type of emissions, well, scientists have developed a unit called CO2 equivalent emissions. And let's talk about the CO2 equivalent emissions. So this lecture has 3 parts: an overview, okay, it's the first part, and I'll give you a definition of CO2 equivalent greenhouse gas emissions, and we look at international initiatives to combat global warming, and I introduce you to emission gap monitoring. Okay, the monitoring of emission gaps. The second part, we look at the sources of CO2 equivalent emissions. So who produces these emissions? Okay. And which sector? Okay, greenhouse gas emissions per sector. Okay, and the last part of this lecture is the blame game. We look at the emissions per country. And we also look at global coal, oil, and gas producers. But let's start with an overview. So a carbon dioxide equivalent is a metric measure used to compare the emissions from various greenhouse gases on the basis of their global warming potential. And the units are million metric tons of carbon dioxide equivalents. Okay, usually expressed per time unit of a year. So the carbon dioxide equivalent for a gas is derived by that simple formula here, where the million metric tons of a gas emitted per year is multiplied with the global warming potential. Okay, and then you get the equivalent effect in terms of CO2. All right, I know you can look it up. You can look up the GWP values from tables, and I just found one table here. Okay, it's a little bit an older table, but anyway, so you can see selected greenhouse gases in this table, like CO2, methane, nitrous oxide, and so on, and shows you the pre-industrial value and the value from 1998. Okay, called recent here, but it's not that recent. Okay. It also tells you the atmospheric lifetime, the residence time of the gas in the atmosphere, and we're talking about this GWP value, which is shown here. Okay. All right. So the GWP for methane is 23, and for nitrous oxide 296, and then you can work out the equivalent. So emission of 1 million metric tons of methane is equivalent to emissions of 23 million metric tons of carbon dioxide, and similar for nitrous oxide. So this is how you now can put them all together and express the greenhouse gas effect in terms of CO2 equivalent emissions. Indeed, noting that CO2 plays the biggest effect. So let's talk about international initiatives. So it all started with the Kyoto Protocol. Okay. With the Doha Amendment of this protocol, and then leading to the famous Paris Agreement. And just have a quick look at these agreements. So the Kyoto Protocol to the United Nations Framework Convention on Climate Change was adopted in 1997. It obliged developed nations to reduce their collective greenhouse gas emissions by 5.2% compared to 1990 levels by 2012. Okay, so the United States, at the time the world's #1 emitter, did not ratify the protocol seriously limiting its effectiveness. Canada withdrew from the Kyoto Protocol in 2011. Okay. So this was amended, the Kyoto Protocol, called the Doha Amendment. Okay. So the second commitment period for the Kyoto Protocol affected only 14% of the global emissions, because only EU member states, other European countries, and Australia had commitments. Okay, the USA, Russia, Canada, Japan, and developing countries did not. So, all right, so that was the starting point of international initiatives, and indeed, it has led to the famous Paris Agreement in 2016. Okay, it's an agreement within the United Nations Framework Convention on Climate Change, dealing with the reduction of greenhouse gas emissions, adaptation, and finance. Okay, signed by consensus by all 197 members, comprising United Nations member states and 189 non-member states. Significant emitters which are not parties to this agreement are Iran and Turkey. Okay. The United States left the agreement from 2020 to 21 under presidency of Trump. Okay, but they are now back in. All right, so the Paris Agreement, and you know all about that, so the key features of that. The Paris Agreement's long-term temperature goal is to keep the increase in global average temperatures to below 2% Celsius above pre-industrial levels, and to pursue efforts to limit the increase to 1.5 degrees Celsius, recognizing that this will substantially reduce the risks and impact of climate change. So this is the big commitment. Okay, it's just a number, 2 degrees Celsius, but it has widespread consequences or commitments. So let's have a look at that. This is the global surface temperature change relative to 1850 to 1900. Okay, and this is the limit here, 2 degrees limit, the Paris Agreement. And this in particular selects a particular pathway, okay, particular emission scenarios. And if you look at the emission scenarios and the predicted temperature changes that you get, it's only the emission scenarios called 1.9 and 2.7 that actually will achieve this goal. Okay? One details that there will be zero emissions by 2050. Okay, and the other one says there will be zero CO2 emissions by 2075. Okay, so that is the commitment. Okay, it's very specific. It talks about zero emissions of CO2 or zero CO2 equivalent gases by the mid or third quarter of this century. So how are we tracking? Well, we are not tracking very well. There are warming projections, and the current projections with current policies look like this in terms of the CO2 emissions, and lead to a global temperature increase by up to 3 degrees Celsius, according to that, the climate models. Okay, and even if we use the optimistic net zero targets, the global CO2 emissions okay, will still stay above the 2 degrees Celsius. So that's what we can do. We can actually work out the emissions, and we can look at and we can predict the future on the basis of these predictions. Okay, and you can see that there is a gap between emissions, okay, and the target emissions, and that's what we call emission gaps. And that's what the gap monitoring is about. Okay, and I will show you some emission gaps per country later in this lecture. Okay. So that's what it is. We're not going through all the specifics of that. But essentially you have your emission scenarios, and that's shown here on the left-hand side, and what you need to do to limit the temperature change to 1.5 degrees, to 1.8 degrees, or to 2 degrees Celsius. And then you have the current, in this case it's 2010 policies scenarios, where you can see still an increase, and the current policy scenarios, which is a little bit lower or so, but still tracking into the wrong direction. And then you can look at different conditional or unconditional scenarios where countries depend on each other. And then you can look at the gap. Okay, and the gap. And this will be critical in the future. Okay? Because the central question is, will the gap get bigger and bigger and bigger? Or will it get smaller and smaller and smaller? Okay, and it's clear that without changes it will continue to increase. Okay, and this is from a recent report called the Emission Gap Report 2022, The Closing Window. Okay, so that's already the end of the first part of this lecture.